We're going to look at converting not just points from polar to rectangular and back, but full-on equations. And as we look at this, we talk about, if you have a rectangular equation such as x squared plus y squared is 9, you can see how much simpler that is in polar. It's just r equals 3. And sometimes it's easier the other way around. A polar equation like this one here looks a lot messier than just writing a straight line equation 2x minus 3y is equal to 6. So with that said, let's take a look on the next page of your notes. We kind of look at this idea that let's start off easy. Here's an easy circular equation. So we've got x squared plus y squared is 4. So it's a circle centered at the origin and a radius of 2. So we know what we're looking for. It says what do we need? And then let's go to pen. So in order to get this into a polar equation, the overarching theme here is we need to solve for r in terms of theta. So I'll write that. Okay. The only thing that we really need to add to our series of tools that we're using from polar and rectangular, it's something we've used before. It's just maybe it's been a little while, like Unit 3. But says what can we use to accomplish this? And the only thing we would probably want to add to our repertoire here is our trig identities. Specifically, we're looking for the Pythagorean identity, which, if you remember, is we take sine theta squared plus cosine theta squared, and that equals 1. So if we get to a part of our equation where we see sine squared plus cosine squared, we can take that whole thing and just replace it with the number 1. I would say that's enough. Let's get moving on to an example. So here we have x minus 4 squared plus y squared is 16, looking like, okay, that's a circle. We can find h comma k, so 4 over 4, and then just on the x-axis. And that's our center point. We draw a circle radius of 4. First question says sketch the graph and identify the graph. So we are a circle, so we want to identify that. And with that, we want to identify the particulars. So center is 4, 0. And our radius is 4. Now, so sketch the graph of the rectangular equation. We can do. I don't have graph paper. I think we can all handle finding the center of 4, 0 and drawing a circle radius 4. And plus, we kind of need the room here for part 2. It says write the equation in polar form. So how do we do this? How do we get to rectangular or from rectangular to polar? It's actually really simple. The process is long, a little bit tedious, but the idea, the theme here is very simple. What we're going to do is anywhere we see an x, we're going to replace it what we know x to be in polar form, and the same thing for the y. So maybe I'll write it up here. I'll say replace x equals r cosine theta. Okay, so we're going to replace our x's with r cosine theta and any y's with r sine theta. So we're going to start with x minus 4 squared plus y squared is 16. Now, anywhere we see our x's, we're going to replace those. So we're going to say r cosine theta minus 4 squared plus equals 16. So the theme or the end goal here, like we say here, what do we need to do? We need to solve for r in terms of theta. So what that means is we need our equation to have r equals and then everything else on the other side. And to do that, let's start by distributing, FOILing any quadratics, things like that, and see what happens. So r cosine minus 4 quantity squared is r squared times cosine squared theta. So that's our first. So this first term squared minus 4 r cosine theta minus another 4 r cosine theta. So minus 8 r cosine theta. And then, so first outside, inside, and then last, so minus 4 times minus 4, we say plus 16. Plus the r sine theta squared, so r squared times sine squared equals 16. So we FOILed out this binomial, and then we just distributed the squared. And at this point, let's see what we can't group together. Well, we have that idea of the Pythagorean identity, sine squared plus cosine squared. So let's see if we can't get those squished together. Just rewrite this r squared sine squared. So I've written the r squared sine squared first, plus r squared cosine squared, and then minus 8 r plus 16 equals 16. Well, when we look at this, we can say, oh, well, let's factor out an r squared out of these first two terms. See, I can write that first two terms as r squared times the quantity sine squared theta plus cosine squared theta minus 8r cosine theta. Now, I'm going to say plus 16 equals 16. I'm going to subtract 16 from both sides in the same line here. So it equals 0. I also see r squared is multiplied by this Pythagorean identity, sine squared cosine squared. So it's really just r squared times 1 minus 8r cosine theta. And that equals 0. So now we have r squared minus 8r cosine is 0. I'm going to say that r squared is equal to 8r cosine theta. Now if I divide by r on both sides, I get r squared over r just equals r. And this whole thing divided by r is just 8 cosine theta. And if you think about the graph of r cosine theta is that graph that's butted up against the y-axis. Center is at 4. In this case, the 8 enlarges it, so it goes from 0, 0 out to 8, 0. And our center then is right in the middle at 4. So we have exactly what we need here. We have a radius of 4 center is at 4, 0, which is where we started. Center 4, 0, radius 4. Go ahead, box that in. And we're done. We wrote the equation, we sketched, well, we didn't sketch it, I guess, but if we had graph paper, we'd sketch it. But the key is identify the graph as a circle and its critical points there. And then we finished our equation. R is equal to some equation in relation to thetas. So I'll end there. I'll do the other example here in a separate video.